Today's video is on integration using residues. In today's video, we are going to integrate around a semicircle. Now, in this video, I am going to evaluate integral 0 to infinity dx by x square plus a square whole square, and also I am going to show that integral 0 to infinity dx by 1 plus x square whole square is equal to pi by 4 using contour integration. So this is the semicircle I'm going to explain you, and this integration is of the type minus infinity to plus infinity f of x dx, whereas here it is given as 0 to infinity. So I am going to change this integral as minus infinity to plus infinity, and I'm going to use the contour integration. And let's get started to solve this, as this question is the most important question. Don't miss this video until then. Please do follow this video. See here, the question given here is 0 to infinity dx by x square plus a square whole square. The distance from 0 to infinity is same as the distance from 0 to minus infinity. So both are equal. So if both are equal, I need minus infinity to plus infinity. So I am writing this as half times of 0 to infinity. See here, the distance from 0 to infinity. So the distance from 0 to infinity is half times of minus infinity to plus infinity dx by x square plus a square whole square. Now see here, the contour given is, we have to consider integral c f of z dz as C is a closed contour consisting of a semicircle. So this is the semicircle. So this is the semicircle consisting of a semicircle, that is mod z is equal to r. So this is nothing but a circle, semicircle, having center 0 and radius r. So this is of radius r and center 0, and this is a semicircle together with the real axis from minus r to plus r. So this is minus r and this is plus r, the real axis, along with the real axis from minus r to plus r, and this is the semicircle with center 0 and radius r. So this is the closed contour, and within this contour we have to find the poles and find the residues, and we have to apply residue theorem. And let's get started. See here, what is it is given. So integral 0 to infinity, integral 0 to infinity dx by, this is x square plus a square whole square. This can be written as half times of minus infinity to plus infinity dx by, this is x square plus a square whole square. Clear? And now, if you see this, so I am transforming this as integral c f of z into dz. So what is our f of z is nothing but I am changing the variable to z. So this will be z square plus a square whole square. First of all, we have to find the poles for it. In order to find the poles, we have to equate the denominator to 0. So if I equate the denominator to 0, that is z square plus a square whole square is equal to 0. And now z square plus a square is equal to 0, and z square is equal to, this is minus a square, and see, if I take root here, this will be minus a square, and z is equal to plus or minus ai. So here z is equal to plus ai and z is equal to minus ai. So this is z is equal to plus ai and this is minus ai are two poles. See here, these are the two poles with order 2. Poles of order, see, 2. As there is square here, so the order here is 2. So we have to check whether which one is inside the contour and which one is outside the contour. If you check this one, so this will be the contour. That is, this is a semicircle. So this is minus r and this is plus r, and this is cr. So this is a semicircle with radius r and center 0. And within this, so here it will be ai, and here down this is minus ai. So comparing with the closed circuit, closed contour, so ai is within the contour. So this ai is within the contour and minus ai is outside the contour. Now we have to find the residue for this. So for finding the residue, let's get started to find the residue for the pole ai. Residue of f of z at point z is equal to ai. As it is of order 2, the formula here is 1 by m minus 1 factorial into limit z tends to z naught. This is d by dz power m minus 1 into, this is z minus z naught power m into f of z. So here m is nothing but, so what is our m value? So m is the order value 2. And what is our z naught? The pole value here is, the interior pole here is ai. If I substitute, I'll be getting the residue for the interior pole ai. So residue value at the pole z is equal to ai is nothing but 1 by 2 minus 1 factorial into, this is limit z tends to, z naught is nothing but ai, and this is d by dz power of m minus 1, this is 2 minus 1 into z minus ai whole square into f of z. So what is f of z here? F of z is nothing but 1 by, this is z square plus a square whole square. Clear? And now I'm going to solve this. So this is the residue value of f of z at z is equal to ai is nothing but 2 minus 1 factorial is again 1 factorial. This is limit z tends to ai. This is d by dz times of. So we have to make a derivative for one time. This is ai, and this can be written as z minus ai whole square into z plus ai whole square. Clear? If I cancel these two and make a derivative, see, for derivative of 1 by x square is nothing but, derivative of 1 by x square is nothing but minus 2 by x cube. X cube. Therefore, the residue value of, the residue of f of z at z is equal to ai is nothing but 1 by 1 factorial is again 1. This is limit z tends to ai. The derivative here is minus 2 by z plus ai whole cube. Now I have to substitute in place of z as ai. So this will be minus 2 by, this is ai plus ai whole cube. Whole cube. Now the residue value will be, the residue of f of z, residue of f of z at the interior pole z is equal to ai value is equal to, this is minus 2 by, this is ai plus ai, so which will be 2ai, 2ai whole cube. Now see here, this is residue value of f of z at z is equal to ai value is equal to, this is minus 2 by 2 cube is 8, a cube is a cube, and this is I cube. As you know that I square value is minus 1. So here I square value is minus 1. So this will be minus 2 by I square, this is minus 1, 8, a cube into I. So if I cancel this minus and also 2 for 4 times, so this will be 1 by 4 a cube I. So this is the residue value of f of z at point z is equal to ai. So we have to apply the residue theorem. For finding the residue theorem, so here is the formula, that is integral c. So integral c f of z dz is equal to, this value is 2 pi I into, this is the sum of the residues, sum of the residues of interior poles, sum of the residues of interior poles. See here, according to which theorem? This is the residue theorem which I am going to apply. According to our residue theorem, integral c f of z dz is nothing but 2 pi I times of. Then what is this integral c f of z dz? So integral c f of z dz is nothing but, c is nothing but the closed contour. So this is nothing but the closed contour with circle 0. So this is r, this is capital R, this is a CR. So the direction here is like this. So the direction here is like this. So this is the closed contour. So this is the semicircle with radius R and center 0. And now we are going to convert the C as from minus R to plus R. See here. So this is from minus R to plus R. So integral C, the closed contour will be from minus R to plus R, and this is the real axis. So this is the real x-axis and this is y-axis. So we can write this as f of x dx plus, and this will be the semicircle curve. So this is a CR into, this is f of z dz. Total closed contour is nothing but the real axis from minus R to plus R, and this one is the semicircle curve, that is a CR, and which is equal to, that is 2 pi I into. So what is the sum of the residues of the interior poles? The residue value for the interior pole z is equal to, here is some ai, is nothing but 1 by, so this is 1 by 4a cube into I. Now if I cancel this one, so what will be the answer here? See, if I cancel for 2 times, and I also, if I cancel, so what will be the answer here? This is minus r to plus r, this is f of x dx, plus this is integral cr, this is f of z into dz value is equal to, this is pi by 2a cube, 2a cube. See, as r tends to infinity, so what happens here? As r tends to infinity, so this will be minus, as r tends to infinity, in place of r I'm writing infinity, minus infinity to plus infinity. F of x is nothing but, this is dx by, the question here is x square plus a square whole square, plus this is the cr. See, so this is CR, from this value is dz by, so this is dz by, this is z square plus a square whole square, value here is pi by 2a cube. And now see here, so what will be this value? So this is equation number 1, and in this equation, so I have to find out this value and I have to substitute in equation 1. See, for considering this one, so here what is this one? CR of f of z dz, I have to consider the value. So this will be dz by, see clearly, dz by, this is z square plus a square whole square. So if you take this substitution here, the substitution here in this is, put z is equal to, so put z is equal to r into e power I theta. If I take modulus here, mod z value will be mod r into e power I theta. Clear? So mod z value is equal to r, I am taking out, so this is nothing but modulus of cos theta plus I sin theta. Clear? So mod z value is equal to r theta into root over, this is cos square theta plus the value here is sin square theta, which is equal to 1. So we got mod z value as r. See, mod z value we got as r. And next thing here is we have to make a derivative. See, again z is equal to r into e power I theta. This is e power I theta. If I make a derivative on both sides, dz is equal to r will be like that. So for e power I theta is again e power I theta, and here I into this one is d theta. So if I take modulus again, mod dz var is equal to r, here will be like that, and this is I times of e power I theta modulus into d theta. See here, mod dz value here is r times of I into, this is cos theta plus this value is I sin theta. Clear? Into d theta. So dz value is equal to r times of, if I send I inside, that is I cos theta minus I square, this is minus, this is a sin theta, into the value here is d theta. For modulus, what we have to do? For modulus, the value here will be again cos square theta plus sin square theta, or sin square theta plus cos square theta. This is minus sin theta whole square. So this will be minus sin theta whole square plus cos square theta into d theta. Again this value is 1. Therefore, mod dz value is equal to r into d theta. So we got mod dz value as r into d theta. And again there is one more substitution, that as you know that, see here, z square plus a square. So z square plus a square modulus is always greater than, this can be written as minus a square. So this value is minus of minus plus a square. So mod z square plus a square is greater than mod z square minus a square. So if I take it as a denominator, that is mod z square plus a square is less than, this is mod z square minus this is mod a square. Clear? And now all these values I am going to substitute here. If I am going to substitute, see, don't feel that this video is very lengthy, as I am giving clear cut idea on each and everything. So here mod z value is how much? Mod z value is equal to r. And from the second thing, mod dz value is equal to, see here, r into d theta. And theta value ranges from, as it is a semicircle, from 0 to 180 degrees. 180 degrees. Now I am going to substitute here all the three values here in the CR. Therefore, integral CR f of z dz is equal to, so this value is dz by, this value is z square plus a square whole square. Clear? So if I take modulus on both sides, mod dz by, this is z square plus a square whole square. So this value will be less than or equal to, for in place of dz I'm going to write r into d theta. So this is r into d theta, and this is from 0 to pi. The limits are from 0 to pi, and this is mod z square plus a square. See here, mod z square plus a square value is less than or equal to, see, this is 1 by mod z square plus a square less than or equal to, this is mod z square minus a square. So I have shown you here. So how it is? And see, this will be mod z square minus a square. And see, in place of z I can write as r, in place of z I can write as r. So this will be integral 0 to pi, this is r into d theta, by this is r square minus a square. So as r tends to infinity, see here, if I substitute, if I take r square common here, if I cancel 1 r, so here 1 by infinity is nothing but 0. So this is going to be 0, that is integral c f of z dz value is going to become 0 from this integral as 1 by r, so 1 by infinity, which is equal to 0 value. Now I am going to substitute this value, this is some 2, I am going to substitute this value as 0. So now here the question here is from 1, so from this integral is going to become 0, and therefore integral minus infinity to plus infinity, integral minus infinity to plus infinity, this is x square plus a square whole square plus 0 value is equal to pi by 2a cube. This value is 0 as I've given you. So this can be written as 2 times of, this is minus infinity to plus infinity, this is 2 times of 0 to infinity, that is x square plus a square whole square is equal to, this is pi by 2a cube, and therefore 0 to infinity, this is dx by x square plus a square whole square value. If I send this 2 to other side, this will be pi by 4a cube. So this is the integral which we are needed, and the next thing here is, and next we have to evaluate. So we got integral 0 to infinity, this is dx by x square plus a square whole square value we got as pi by, this is 4a cube. And next, what is asked in the question to show that? So it is asked to again show that integral 0 to infinity dx by 1 plus x square whole square is equal to pi by 4. So on comparing with this, in place of a square we have 1. So in place of a square we have 1, and obviously a is equal to 1. If I substitute integral 0 to infinity dx by, so this is x square plus 1 whole square value will be, this is pi by 4 into, in place of a as 1. Therefore integral 0 to infinity, this is dx by, this is x square plus 1 whole square value is equal to, this is pi by 4. So this is how we have to show that, and let me explain you once again. So now we have to show integral 0 to infinity dx by x square plus a square whole square using the residue theorem. So first of all, this is a semisphere, that is with center 0 and radius r, and this is the semicircle. So this is the semicircle. So we have to consider C as a closed contour consisting of a semicircle, and together with the real axis minus r2 plus r. So this is the real axis, and this is the semicircle with radius r and center 0. And now what is the integrand here? That is, in order to find from 0 to infinity, which is equal to half times of minus infinity to plus infinity dx by x square plus a square whole square. So here the total integral c into f of z dz is nothing but dz by z square plus a square whole square. In order to find the poles, we have to equate the denominator to 0, and after equating we got the two poles. These are the two poles of order 2. So this is the closed contour which is a semicircle along together with the real axis from minus r to plus r. Here if you see, plus ai is inside and minus ai is outside the semicircle. So for interior poles we have to find the residues. So for residue of order, for pole of order 2 we have to find the residue using this formula. So here m value is equal to 2, order value, and z naught value is equal to ai, which is the interior pole. And after substituting and calculating, so we got the residue value as this one, that is 1 by 4a cube into I. And now using the residue theorem, we have to multiply with 2 pi I. So after multiplying with 2 pi I, so we got the residue value as pi by 2a cube. See here, so this is the total closed curve C. So the closed curve C is nothing but the real axis, that is minus r2 plus r f of x dx, as it is x-axis, and this is the semicircle, that is CR is equal to f of z dz. So we have to find out the integral value of this one. As r tends to 0, this r value is going to tend as minus infinity to plus infinity, and this is CR f of z into dz. So now I have to find out the value of this integral. So in order to find out the value of this integral, so we have to substitute z is equal to r into e power I theta, and we have to take modulus on both sides, and after taking modulus, this is going to become 1 and mod z is equal to r. And next one, z is equal to r into e power I theta, we have to make a derivative for finding dz value, and after taking modulus on both sides, so and after taking root over minus sine square theta plus cos square theta, again 1, mod dz value is equal to r into d theta. As you know that z square plus a square is always greater than mod z square minus of minus a square. So if I bring it to the denominator, so this greater than value will be less than value. So all these values if I am going to substitute here, so in the given integral, so here is the integral, that is dz by z square plus a square whole square. So in place of mod dz as r into d theta, and in place of z square plus a square, 1 by z square plus a square, which is less than or equal to z square minus a square, and in place of z I can write as r. So just now I have found mod z is equal to r, put z is equal to r here, so this will be r square minus a square. As r tends to infinity, so if I cancel, if I take r square common from this and cancel, 1 by r times of something remains. So 1 by infinity, as r is tending to infinity, so 1 by infinity value is 0. So this integral value is going to become 0, that is integral CR f of z dz value is 0. So if I substitute the same thing here in this, so this integral CR f of z dz, so this is integral, this value is going to become 0. Now what remains here, this is minus infinity to plus infinity, dx by x square plus a square whole square is equal to pi by 2a cube remains. So this can be written as 2 times of 0 to infinity dx by x square plus a square whole square, which is this one. And if I send 2 to other side, so this will be the answer. And the next thing we have to show that this integral, so in place of a if I keep 1, so 0 to infinity dx by x square plus 1 whole square value is equal to pi by 4. This is how we have to solve. Please, even though the video length is very lengthy, don't miss, each and every step is very important. I have explained vividly, and if you have a clarity in each and every step, you can do by your own, and your preparation will be very simple and easy if you follow this video. And I'll be uploading many more solutions among this improper integrals. Please do follow and subscribe to this channel. Thank you so much.